We are going to just take over where we left off on page 39 to continue this lesson. And where we left off, we had just computed a residual for a value for an observation. And if you remember, x was 103. And so if we go over here, that means that we're interested in this value. This value has an observed observation and a predicted. The y value, where the dot is the observed. And that was about 274. And then it's also got a predicted value. That's where the line was. Oops. So right above 270. So we have the observed at 274, the predicted, and the residual then is the distance between the observed and predicted. Is this distance right here. And we know that distance is 3.29. So the line was off by 3.29, and because this is positive, we know the observed was greater than the predicted. So anything above the line is going to be positive. Anything below the line is going to be negative. And so each observation has a distance to the line. This is the observed, this is the predicted, that distance is the residual. So residuals can be positive or negative. Okay, so we're going to move on. One important thing that we're interested in with linear regression is to interpret the slope of the problem. There are times when we want to interpret the y-intercept. The slope is much more common though. So the slope, like you learned in algebra, is just rise over run. On the graph here, the slope indicates the rate of change. So the steepness of the slope indicates how fast the distance changes with respect to speed. And the slope tells us if we increase x by 1, the line's going to increase or decrease by the slope. And so the slope for this problem, if you remember, was 3.17. And so for every one, let's see, I think we are miles per hour. So for every 1 mile per hour increase in speed of the golf club, the distance will increase by 3.17 yards. So the slope means for every change of 1 unit in x, so 1 mile per hour with the golf club, y is going to increase by the slope. So the distance is going to increase by 3.17 yards. Okay, so let's just fill in the blanks here. So this is 3.17, just rounding the 166. And the y-intercept, that's the other number that doesn't have a coefficient for x. So that's 796. Oops. Alright, so we just went over the slope. If the club head speed increases by 1 mile per hour, then the predicted distance would increase by 3.17 yards. And so some problems we would want to interpret the y-intercept as well. And if you remember back from your days of algebra, you know the y-intercept is where the line crosses when x is equal to 0. This particular problem doesn't make sense because if the golf club speed is equal to 0, then it can't hit the ball. And so for this particular problem, we're not going to interpret the y-intercept. Alright, so let's move on to a different problem. Here's an example. It says crickets make a chirping sound by sliding their wings rapidly. Perhaps you've noticed that the number of chirps seem to increase with the temperature. The following data lists the temperature in degrees Fahrenheit and the number of chirps. Okay, so we have some data here, temperature and chirps. First thing we'd want to figure out is what the explanatory variable would be and what the response variable. So it makes sense that the number of chirps per second is somehow explained, at least in part, by the temperature outside. And so the temperature is going to be the explanatory variable. And the other variable would be the response, which would be chirps. All right, next thing we want to do is compute the least squares equation of the line. So I'm going to do this both in the TI calculator as well as in StatCrunch. So let's do the TI calculator first. The first thing we would do is enter our data, x in L1 and y in L2. And I've already done that. So the next thing we'd want to do is go to Stat, then Calculate, and then we go down to number 8. Which is linear regression. And then I just hit enter twice. And then it gives me my y-intercept and my slope. And so what I want to do is I want to come over and just write the equation of the line. And I have to write that out as an equation. And so I would start out writing y hat. The hat, remember, means prediction. It's equal to negative 0.309 plus 0.212 times x. Okay, so when you write out the equation of the line, you have to write y hat plus the intercept plus the slope times x. Okay, so let's interpret the slope. Oh, let's do that in StatCrunch too. So if I come over to StatCrunch, I have the data entered already. I can go to Stat, then Regression, Simple Linear. And we said the x is temperature, the y is chirps, and then I'm going to hit Calculate. Okay, so here's my equation of the line. They use the actual variable names in there, but we have this y-intercept and the slope. They're also reported down here. Correlation coefficient as well. Alright, so let's go back to the problem. And we want to interpret the slope in context of the problem. So what that means is I want my interpretation to include temperature and chirps. And so I would say something like for every degree increase in temperature, the number of chirps per second increases, because the slope is positive, by 0.212. So that is what the slope means in context of the problem. We're increasing x by 1 unit, so 1 degree, then y is going to increase by the slope, so 0.212. Alright, so why doesn't it make sense to interpret the y-intercept? The y-intercept would be the number of chirps when the temperature is 0. And certainly the temperature could equal 0, but we don't have any data near 0. They all are in the range of 60s, 70s, or 80s. And so we call that outside the range of the data. So we don't know if the model is going to stay linear outside the data that we have. So I say something like 0 degrees is outside the range of data collected. So it's not safe to make a prediction at that value for x. Okay. Now we're going to use the equation to make a prediction for 75.2. So I just want to use this equation and substitute a value in for 75 x equals 75.2 into the equation. Alright, so I have y hat is going to be equal to negative 0.309 plus 0.212 times 75. And that's going to be equal to 15.591. And that's chirps per second. Alright, and then last thing we want to do is compute the residual. So remember, the residual is the observed minus predicted. So y minus y hat. And let's see, we know our predicted for 75, whoops, I didn't do it for 75.2. Hold on a second. Alright, so this is going to change a little bit. Just going to cross this out. If I put 0.2 there, this changes to 15. We'll just round it to 0.6. So it didn't really change very much. Okay, now I want a residual. We have the predicted value, and I also need an observed value for 75.2. It says the observed value was 15.5. That's what we're given in the problem. So I take the observed minus the predicted. That's equal to negative 0.1. So it's negative. That means it was below the line. The observed value was slightly lower than the line than the predicted.